What's meant by physical quantity? Physical quantity, it is any quantity that can be determined or measured, and it has a unit of measurement in our daily life. For example, mass is measured in kilogram, and it has a measuring device. Length, it is measured in meter. Time, measured in second. Speed, measured in meter per second. Force, measured in Newton. Energy, measured in joule. Temperature, in Kelvin, degrees Celsius, but we are using Kelvin. Velocity is measured in meter per second. Pressure is measured in Pascal or Newton per meter squared. Displacement measured in meter. Acceleration measured in meter per second squared. So any quantity which has a measuring unit and can be measured, it's called physical quantity. We have two types of physical quantities. One is called scalar and the other is called vector. Scalar physical quantity, it is the physical quantity which has magnitude only. It has no direction. But what's meant by vector physical quantity is the physical quantity which has magnitude and direction. For example, if the object started motion from point A, then this object covered the whole distance, then reached point B. So if I'm telling you that the distance covered by this object is equal to maybe 5 kilometers, you don't need to know any extra information. This 5 represents the value, and this kilometer represents the unit. Unit plus value represents magnitude. So what's meant by magnitude is just a value followed by a unit. So if any physical quantity that you are dealing with, you need just to know its magnitude. So this physical quantity is called scalar physical quantity, like distance. The distance that I cover today is 3 kilometers, for example. Mass, the mass of this pen is 300 grams. Time, the time of our class is 50 minutes. Temperature, the temperature of today of our human body is 37 degrees Celsius. And to convert from degrees Celsius to Kelvin, you just add 273. For example, 337 plus 273, it will be maybe 310 plus 273, it will be 310 Kelvin. So 310 Kelvin is equivalent to 37 degrees Celsius. They are the same. Energy. For example, the consumed energy is 10 joule. Done. Direction is not needed. We only need to know the value followed by the unit, which represents the magnitude. No direction is needed. In this case, distance, mass, time, temperature, energy, they represent scalar physical quantity. We have other physical quantities. For example, we have length, we have width, we have height, we have radius, we have diameter, we have circumference, we have pressure. Pressure, by the way, is scalar. We have power. They are scalar physical quantities. What about vector physical quantities? For example, if this is my initial position and I am telling you that I will cover 5 meters, and I want you to just tell me what will be exactly my final position. You can't, because I need to specify the direction. But what if I am telling you that I will cover 5 meters to the north? Then you will move 5 meters to the north and you will tell me that this will be my final position. In this case, if I'm telling you a distance followed by a direction, this is not distance, this is called displacement. And as you can see, displacement has magnitude, which is value followed by unit, and direction. In this case, it was to the north. So we have displacement. It is a vector physical quantity because it has magnitude and direction. Velocity. Velocity, it is the rate of change of displacement. So it depends on displacement, which is vector. So this is the reason that velocity is also a vector. Acceleration. Acceleration is the rate of change of velocity. So acceleration depends on velocity, which depends on acceleration, which depends on the displacement. So acceleration is vector. Force. Force is equal to m times a. This is called unbalanced force is equal to the product of mass and acceleration, and this is also called Newton's second law. So as you can see, acceleration, it is the rate of change of velocity. Velocity, it is the rate of change of displacement. Displacement is vector, and velocity depends on displacement. Acceleration depends on velocity, and force depends on acceleration. So force is also a vector. We have other physical quantities which are vector, like linear momentum, which is equal to mass times velocity. Velocity is a vector, so also momentum will be a vector. Okay, so any physical quantity which has magnitude and direction, it is called vector physical quantity. But any physical quantity which has magnitude only and direction is not needed, in this case it is called scalar physical quantity. We have something that can help. In math, we have sign rule, in which if we have two positive numbers and we multiply them, we will have another positive. What if we have two negative numbers and after multiplication we will have also a positive number? But if we have a negative times positive, it will be negative, and also if you have positive times negative, it will be also negative. This is also true with division. So since vector physical quantity has a direction, so it may be in a certain direction or in the opposite direction. If it is to the right, for example, it will be positive. If it is to the left, which means the opposite direction, it will be negative. Negative in physics, it is not a value. It just means the opposite direction. So if we have a vector physical quantity, I can add just negative. But if we have a scalar physical quantity, it's always positive because the direction is not needed. So by this way, you can decide if this physical quantity is scalar or vector. I will give you an example. For example, velocity is equal to displacement divided by time. You know that displacement is a vector, so I will put negative. But also you know that time is a scalar, so I will put positive. So negative divided by positive, it will be negative. So velocity is vector because it could be negative. Another example, acceleration, it is equal to the rate of change of velocity. So velocity is vector, so I will put negative. Time is a scalar, I will put positive. Negative divided by positive is negative. So acceleration is vector. Force is equal to mass times acceleration. Mass is a scalar, so it's positive. Acceleration is vector, so I will put negative. Positive times negative is negative. So force is vector. Work equals force times displacement. Force is vector, so I will put negative. Displacement is vector, so I will put negative. Negative times negative is equal positive, so work is a scalar, and so on. Pressure is equal to force over area. By the way, area is vector. You can search. Force is vector, so it's negative. Area is vector, so it's also negative. Negative divided by negative is equal to positive, so this is the reason that pressure is scalar, because the direction is not needed. Pressure acts on all directions. So if we have a physical quantity which has only magnitude, this is called scalar physical quantity. If it has magnitude and direction, it's called scalar. It's called vector. And you can use my formula just to decide if this physical quantity is a scalar or vector if you know just its formula. We have an example for scalar physical quantity, and we have another example for vector physical quantity. If this is your starting point and this is your ending point, and this is the actual path that you have covered, this is called distance. But if this is your initial position and this is your final position, and this is the shortest straight line from the starting point to the ending point, this virtual line because this is not real. This virtual line represents displacement. And for this displacement, we need two pieces of information. We need to know the length of this vector, which means its magnitude, and also we need to its direction. So direction and magnitude, because displacement is a vector. But here we need only the magnitude. We need just to know what is the total distance that you have covered today. So what's meant by distance? It is the length of the path moved by an object from a position to another. But what's meant by displacement? It is the length of the straight line segment in a given direction. Can you see? In a given direction between the starting point and the end point. Distance is a scalar physical quantity because it has magnitude only. But displacement is a vector physical quantity because it is fully defined by knowing its magnitude and direction. We need both. We need magnitude and direction. So displacement is a vector, but distance is a scalar. Let's solve some questions. A rubber ball fell from 50 centimeter high. So this is the initial position, and it fell from 50 centimeter high and kept bouncing along a vertical path as shown. The total distance it covered and its displacement are. So we need the total distance first, then we need the displacement. The total distance, we will add them all. The first distance is 50 down, then 30 up, then 30 down, then 10 up, then 10 down, then it's done. So the total distance covered in this case, this is 110, 20, 30. So it will be 130 meters. And the direction is not needed. So this is wrong, right, wrong, right. So the answer is B or D. What about the displacement? Displacement, it is not interested in the details. It's only interested in where is the starting point. This is the starting point. Where is the ending point? This is the ending point, which is exactly like this one. So what is the straight line between them? Its length is 50. So the magnitude is 50, but 50 centimeters. But this is only the magnitude. What about the direction? We can say south or downward. This is the direction. So this is centi, right? So 50, 50, wrong, wrong. So the correct answer is B. Another question. In the opposite diagram, a person has moved from point A, this is the starting point, to point E, this is the ending point, passing by points B, C, and D. His displacement. So now we need first to know the displacement, which is a vector quantity, and the distance. He moved R, respectively. Let's start with the distance, because it is easier to be calculated. We have 60 up to the north, then we have 60 to the right, to east, then we have 40 up to the north, and we have 40 to the right or to the east. So here we have 100 and we have another 100, so the total distance is 200 meters. But this was the second part, right? So this is right, wrong, right, right. So the answer is not B. It can be A, C, or D. How can we calculate the displacement? The displacement is equal to the shortest straight line covered by the object from the starting point to the ending point. So it is the shortest straight line between the starting point and ending point. Can you see? This is a right angle triangle. So we can find the length of this hypotenuse by using Pythagoras theorem. And this is also a right angle triangle. So we can find the length of this hypotenuse by using also Pythagoras theorem. Then we will add the length of this hypotenuse to this one. So this will be the total displacement. So displacement is equal to the length of AE. But we need to calculate it in 3 steps. First, to find the length of AC, then to find the length of CE, then we will add them together to find the total length of AE, which represents the displacement. So to find the length of AC, we need to find the square root of 60 squared plus 60 squared. So it will be 60 root 2 meter. To find the length of CE, we will do the same. We will square each side 40 squared plus 40 squared, and we will add them under the square root. It will be 40 root 2. Then, to find the length of AE, we will add them. It will be 60 root 2 plus 40 root 2, so it will be 100 root 2, which I think it will be 140. Yeah, it's 141.4, I think. So let's use the calculator. So it's 60 root 2 plus 40 root 2. It's 140. Yeah, it's 141.42. The unit is meter. This is the magnitude. How can you specify the direction? This is the north, this is the south, this is east, this is west. As you can see, this displacement is from A going up. So it's between north and south. So north, east. Or sometimes you can say north of east or east of north. Or you can just specify this angle by using drag. But we don't need this. So this is wrong, this is wrong, this is right, this is wrong. So the correct answer is number C. What if we have many forces which are acting on the same object? We said that force is vector, right? So we have an object, and this is the y-axis, this is the x-axis. What if this object is affected by a force which is equal to 3 Newton to the right, and also it is affected by another force which is equal to 3 Newton to the left. So when we add these two forces together, 3 plus 3, it is not equal to 6. Why? Because this 3 is in the direction of the positive x-axis, so it will be positive. This one is in the direction of the negative x-axis, so it will be negative. So the sum, sigma means sum, means the total. The sum of all forces on the x-axis will be equal. We will add them, but with keeping their sign. So this is 3 in the direction of positive x, so it will be positive 3. There is no need to write this positive. But this is 3 in the direction of negative x, so it will be negative 3. So the total will be 0. This is called balanced forces. Balanced forces mean they will cancel each other. What if we have another force which is 10 Newton upward, but we have another force which is equal to just 4 Newton downward? This is the y-axis, so this is the positive y, downward is the negative y. So we'll do the same. We will find the sum of all forces on the y-axis. We will add them also, but with taking their directions into consideration. We have positive 10 because it's pointing upward in the direction of positive y, so it is positive 10, and we have 4 in the negative y direction, so it will be negative 4. 10 plus negative 4 is equal to positive 6. So now we have 4 forces. Now we can just remove these all 4 forces and add just one force upward. Its magnitude is 6 Newton. This force, it's called resultant force, or it's called net force, or it's called total force. So this is the force, this is a single force which produces the same effect done by 2 forces or more. So now we have 4 forces. We just convert them into a single force which will do exactly the same effect done by the 4 forces. But this one will be easier to be calculated. Then we can use Newton's second law, which states that the sum of all forces, which is the net force, is equal to mass times acceleration. So if you know that the mass of this object is equal, for example, 2 kilograms, and I'm asking you to calculate its acceleration, you will just get rid of this mass by division. So acceleration will be equal to force over mass. Force, the resultant force, is equal to 6 Newton. Mass is equal to 2. So the answer will be 3 meters per second squared. And we will study acceleration in details. Don't worry. but this one means that the velocity of this object will increase by a rate of 3 meters per second each second. For example, if this object started motion from rest, so its velocity was 0, then after 1 second it will be 3 meters per second. After another second it will be 6 meters per second. After a third second it will be 9 meters per second, and so on. Its velocity is increasing, but in a uniform rate, with a uniform rate. We have another question for this one. The opposite figure, which is this one, represents a body which is affected by several forces. The figure representing a body that is affected by the same resultant force is which one? We will do what we have done before. As you can see, this is the y-axis. So this is positive y, and this is negative y. This is x-axis. So this is positive x, and this is negative x. So this object will be affected by two forces, one over the x-axis and the other over the y-axis. So we will add the forces on the x-axis. This is positive F, but this is negative 2F. So the total is negative F. You can use your calculator. It's 1 minus 2, or 1 plus negative 2, it will be negative 1. What's meant by negative 1? It means that it is a force which is pointing toward the left. So this is the sum of all forces on the x-axis. We will do the same for the y-axis. The sum of all forces on the y-axis will be equal. This is positive y, but this is negative y. So we'll add them together. This one is positive F, but this one is negative half F. So the total will be positive half F. Positive means upward. So it's positive half F. So this is the two forces which are equivalent to the same four forces. We will try to see the forces which are acting on the choices. As you can see, this is half F upward, which is correct. But this is F to the right. No, it is F to the left. So this is not correct, because vectors, to have exactly two equal vectors, they must have the same magnitude and they must have the same direction. What about this one? This is the y-axis. So this is positive y. This is negative y. So the sum of forces on the y-axis is equal to positive half F plus negative F. So it will be negative half F. So this object is affected by a force which is downward, which is equal to half F, which is wrong. So there is no need to continue. What about this one? Positive half F upward, which is correct. 2F, which is wrong in magnitude, and also it is wrong in the direction because the force should be to the left. So this is also wrong. What about the final one? This is the y-axis. So this is positive y. This is negative y. So the sum of all forces on the y-axis, it is equal to positive 3 over 2F plus this is negative F. So it will be half F. So we have an object which is affected by a force which is equal to half F upward. This is the x-axis, but this is positive x, and this is negative x. So we will find the sum of all forces over the x-axis. So this is positive half F plus this is negative 3 over 2F. So the result will be negative F. Negative means to the left. So this shape is exactly the situation that we have. So the correct answer is number D. We have another example. In the opposite figure, there are four forces which are acting on a body where the resultant and the angle that the resultant makes with the horizontal are space and space respectively. So this is the y-axis, this is positive y, and this is negative y. So first we need to find the sum of all forces over the y-axis. So this is positive 3F plus this is negative F. So it will be positive 2F. So this is the object, and it is affected by a force of 2F upward. Why upward? Because it is positive. Then This is the x-axis. So this is the positive x, and this is the negative x. So the sum of all forces over the x-axis is equal to positive 3F plus negative 2F. So it will be just positive F. So we have another force to the right. Why to the right? Because it's positive, which is equal to F. According to your syllabus, this is the end. The steps that I'm doing right now is just an extra step. It's just an extra step, okay? Just extra step. We can just move the vector. This will not affect its value. So now we have two vectors. To add these vectors, we have here something which is called tail, and here we have head. If you join this tail to head, this is the resultant. This is their summation. So now we have a right angle triangle. To find their summation, we find the length of this hypotenuse. So the resultant force of x and y, it will be square root of f squared plus 2f squared. You are not required to do this one. So it will be root 5f. So this is wrong, right, wrong, right. So it's B or D. How can you calculate the direction just by finding this angle? You can find this angle from trig. This side is called the opposite to the angle, and this one is called the adjacent. So tan theta is equal to opposite over adjacent. So if you want to find theta, you will find tan inverse to opposite, which is 2f, over adjacent, which is f. You will cancel this one with this one. So you will use your calculator to find shift 10 to 2. So the angle is 63.43 degrees. So this means that the resultant force is making an angle 63.43 with the positive x-axis. So this is right, wrong, wrong, right. So the correct answer is number D. Now we will talk about motion, displacement, velocity, and finally acceleration. So what are the states of the object? The object may be static. Static means it will not move, or it can be a moving object. So what's meant by static object? If we are just drawing a relation between the position of the object and its time, we will find that as time passes, the position of the object doesn't change. So this object has a fixed position. For example, 10 meters from the reference. If this is the reference and this is the object, and the distance between the object and this reference is 10 meters, for example, so this is 10. So after 1 second, it's 10. After 2 seconds, it's still 10. After 3 seconds, 10. After t seconds, it's still 10. So this means that this object is not moving. There is no change in his position. So what's meant by static object? It is the object that does not change its position relative to a given point, which is the reference with time. But what's meant by a moving object? If this is the position of the object, and this is the time taken to move, and this is the relation between them, so this means that this object is moving, but also this object is moving with the uniform velocity. For example, if during the first second this object covered 10 meters, after 2 seconds this object covered 20 meters, after 3 seconds this object covered 30 meters, after 4 seconds this object covered 40 meters. So this means that this object is covering a fixed displacement over the same time. For example, can you see? It's just 10 over 1, so it will be 10 meters per second. So this object is covering 10 meters each second. So when we have a moving object, this object is moving with velocity. How can we calculate its velocity? Velocity is equal to the rate, anything which starts with the word the rate of. So it means that we have something which is divided by time. The rate of a change of displacement. So what's meant by velocity? It is the change delta. This triangle is read as delta, and it means change in displacement divided by the change in time. This is what's meant by velocity. So velocity is the rate of change of displacement, or it is the displacement of the object in 1 second. So how can we calculate the change? Just by subtracting the final position minus the initial position over the final time minus the initial time. So if you just do final position minus initial position, this is called the change in the position, which is displacement. Then you do T2 minus T1, which means the change of time. If you divide the change in position divided by the change in time, this will give the velocity. So we have a triangle in which velocity is equal to the change in position divided by the change in time, or displacement over time. If you want to find the velocity, you just divide displacement by time. But if you want to find displacement or time, you will just divide displacement by velocity. What if you want to calculate the displacement? You will just multiply velocity times time. The measuring unit of velocity is meter per second or kilometer per hour, because velocity is equal to displacement over time, or the change of displacement over the change of time. Displacement is measured in meter or in kilometer, but time, it can be measured in seconds or in hours. So we can just create a table. We have displacement, and we have time, and we have velocity. If displacement is measured in meter and time is measured in second, so the measuring unit of velocity will be meter per second, or meter dot second power -1. They are the same. But what if the displacement is measured in kilometer and time is measured in hour? In this case, the velocity is measured in kilometer per hour. We have other cases in which distance or displacement is measured in kilometer and time is measured in minute. So in this case, the measuring unit of velocity is kilometer per minute. And finally, what if the displacement is measured in kilometer, time is in second, so the measuring unit of velocity is kilometer per second. But this is the standard. We are measuring the speed in a unit which is called meter per second. This is the standard. What if we have the velocity which is measured in kilometer per hour and we need to convert it into meter per second and vice versa? We do this. So what if we have a unit which is kilometer per hour and we want to convert it into meter per second? Kilometer per hour, it is exactly as kilometer over hour. Meter per second, it's equal to meter over second. To convert from kilometer into meter, we multiply by 1000. To convert from hour to second, we can't do this directly. We need to do it in 2 steps. 1 hour contains 60 minutes, and each minute contains 60 seconds. So to convert from kilometer per hour into meter per second directly, you multiply by 1000 over 6 times 60 is equal to 3600. This number in the simplest form is equal to 5 over 18. So this is exactly the number that you can see. So to convert from kilometer per hour into meter per second, you multiply by 1000 over 3600 or 5 over 18. What if you want to do the opposite? If you want to convert from meter per second into kilometer per hour, you can just divide by the same number. Or you can just multiply by the reciprocal. Reciprocal means the multiplicative inverse. So it will be 18 over 5. Okay? So we have an example. What if we have a velocity which is equal to 72 km per hour? So to convert it into meter per second, you multiply by 5 over 18. So divided by 18 equal 1, divided by 18 equal 4. Yeah, it's 4. So 4 times 5, it's equal to 20 meters per second. So this means that 20 meters per second is equivalent to 72 kilometers per hour. They are the same, but with different units. What is the difference between speed and velocity? By the way, speed is a scalar. It has magnitude only. but velocity is vector. It has magnitude and direction. Each one of them, their definition is the same. It's the rate of change of something. Speed, it is the rate of change of distance, but velocity, it is the rate of change of displacement. So what's meant by speed? It is the rate of change of distance. Velocity, it is the rate of change of displacement. This is the reason why speed is scalar, because it depends on distance, which is scalar, and time, which is scalar. Do you remember? Positive divided by positive is equal to positive. But velocity, it's equal to the change in displacement, which is vector, over the change in time, which is scalar. Vector divided by scalar, it will give vector. Negative divided by positive, it will give negative. So velocity is vector. So what's meant by speed? It is the rate of change of distance, or it is the distance covered in 1 second. What's meant by velocity? It is the rate of change of displacement, or it is the displacement covered in 1 second. So what's meant by speed? It is the distance moved by the object per unit time, or per 1 second. What's meant by velocity? It is the displacement of the object per unit time. What is the type of speed? It is scalar. It has magnitude only. Velocity, it is a vector. It has magnitude and direction. Since speed is scalar, so it is always positive. But since velocity is vector, it may be positive or negative. If the object is moving to the right, so it is moving with positive velocity. If this object is returning back to the left, so this object is moving with negative velocity. Positive if the object moves in a certain direction, negative if it moves in the opposite direction. Example for the speed, a car moves at a speed of 80 km per hour. If you want to convert it into meter per second, you just multiply by 5/18. Example for velocity, a car moves at velocity of 80 km per hour, but to the east. East is the direction. 80 km per hour is the magnitude. 80 is the value, kilometer per hour is the unit, value plus unit is the magnitude, and east is the direction. So this is the difference between speed, which is scalar, and velocity, which is vector. Also, what is the difference between average speed and average velocity? Average means total over total. So average speed, because it is average, it is equal total over total. But since it is speed, so it's total distance over total time. By the same logic, average velocity, it's also equal total over total. But in displacement, there is no total, because displacement is not interested in details. It's only interested in where is the starting point, where is the ending point, what is the shortest straight line between them. So it's equal to the displacement, because it is vector, over total time. So this is the difference between average speed and average velocity. So what's meant by average speed? It is given by dividing the total distance. Can you see? Distance of the object from the starting point to the end point by the total time. Total time. But what's meant by average velocity? It is given by dividing the total displacement of the object from the starting point to the end point by the total time. So can you see? Here we have displacement. Here we have distance. But what is the difference between average speed and speed? Average speed, we are taking the total distance divided by total time. The type of average speed, because of course it's scalar, but average velocity is vector. The formula, total distance divided by total time is equal to average speed. Average velocity is the displacement divided by total time, it's average velocity. What is the difference between uniform velocity and non-uniform velocity? If we have an object, this object covered 5 meters during the first second, then covered another 5 meters in the next second, then covered another 5 meters in the next second. So this object is moving with uniform velocity. and we will find that uniform velocity means zero acceleration, because this object is covering the same displacement through the same interval of time. Can you see? Each 1 second, this object covers 5 meters. So its velocity will be 5 meters per second. 5 meters per second means this object is covering 5 meters each second. So to calculate its velocity, you just find the total displacement divided by total time. The total displacement done during the first second is 5. It's displacement over time. Over time, which is 5 meters per second. But to find its average velocity, you will find the total displacement divided by total time. So the total displacement in this case is 5 plus 5 plus 5, which is 15. The total time is 1 plus 1 plus 1, which is 3. It's 5 meters per second. Can you see? The average velocity is equal to the instantaneous velocity. This is because this object is moving with uniform velocity. Also, can you see? 5 divided by 1, it's also 5. 5 divided by 1, 5. So the speed is constant. If you have constant speed, if you have regular speed, if you have uniform speed, they are the same. But what if, I will duplicate this slide. What if we have another object? This object just covered 5 meters during the first second, then covered 10 meters during another second, then covered 20 meters during a third second. Can you see? The velocity of this object is not constant. This object is speeding up. So we can calculate its speed during this interval by dividing the displacement, which is 5, divided by time, which is 1. It will be 5 meters per second. We will calculate its velocity here by dividing the displacement, which is 10, divided by time, which is 1. So it will be 10 meters per second. Can you see? We have a different value for the velocity. Finally, we can calculate its velocity here by dividing the distance or displacement divided by time. So it will be 20 meters per second. So the velocity is increasing. So this object is moving with non-uniform velocity, increasing velocity. So this object has positive acceleration. But also, what if the object just covered 5 meters during the first second, then 10 meters during the second second, then covered just 2 meters during the third second? So the velocity of this object here is 5 meters per second, 5 divided by 1. The velocity here is 10 divided by 1, so it's 10 meters per second. The velocity there is 2 divided by 1, it's 2 meters per second. So this object was increasing, its velocity increased at the beginning, then it decreased. So also this object is moving with non-uniform velocity. So what's meant by uniform velocity? The velocity in which the object moves through equal displacements in equal intervals of time. But what's meant by non-uniform or varying velocity? The velocity in which the object moves through unequal displacements. Can you see? 5, 10, 20 in equal intervals of time. Can you see? 1, 1, 1. So the time is constant, but the magnitude of displacement is variable. So if you represent this relation graphically, you will find that the displacement and time, they are directly proportional and the relation between them is linear. For example, 1 with 10, 2 with 20, 3 with 30, 4 with 40. This means that the velocity of this car is just 10. Can you see? It's kilometer. And this one, it should be in hour maybe. So the unit will be kilometer per hour. But if this one is in meter and this is in second, so it will be 10 meters per second. But what about this object? This object just covered 20 kilometers during the first second. Then, after 2 seconds, the total displacement was about 25. So it just covered 5 kilometers during this second. After 3 seconds, the total displacement was 30. So it just covered 5 kilometers during this third second. There is a difference between the third second and 3 seconds. Third second is still a second. 3 seconds? No, they are 3 seconds. What is the total displacement after 4 seconds? It's 14. But during the 4th second, this object covered only 10 kilometers. So as you can see, the time is constant, but the magnitude of displacement is variable. So this object is moving with non-uniform velocity. When the object is moving with non-uniform velocity, its acceleration is not equal to 0. This object will have an acceleration. But when the object is moving with uniform velocity, its acceleration will be 0 because there is no change in its velocity. The velocity is constant, so there is no change. Because as you can see, acceleration is equal to delta v over delta t. Delta means change, so it's equal to final velocity minus initial velocity over delta t, which is t2 minus t1. Now, what is the difference between instantaneous velocity and average velocity? Instantaneous velocity means the velocity at a certain instant. For example, if this is the position time graph, and the relation between them is just direct linear relation. So the instantaneous velocity in this case will be exactly the same as average velocity, because average velocity is equal to the total distance covered, which is this one, divided by the total time, which is this one. So you will divide the total distance divided by the total time, right? And it will be exactly as the value of any instantaneous velocity here. But what if this object was moving with non-uniform velocity? For example, non-uniform increasing velocity, like this one, or non-uniform decreasing velocity, like this one. So this velocity is increasing, and this velocity is decreasing until the object becomes static. So what if the object its velocity is increasing? What if this is 2 seconds? What if I am asking you to find its velocity after 2 seconds? Here, you can just tell me that since the position is 10, you just divide 10 by 2, which is equal to 5. This is wrong. Why? Because velocity is not the position, it is the change in position divided by time. This is the position. You need to find out what is the value of the change in position. So you need 2 points, because change in position equals final position minus initial position divided by t2 minus t1. So what we can do, we have only just 1 point. In this case, we draw something which is called tangent. Tangent is just a straight line which is touching the graph in the point that we are interested in. Then this graph, it has unlimited number of points, so we can choose any two of them. For example, this one and this one. Now we have final position, and we have initial position, and we have final time, and we have initial time. So we can substitute in this relation and we can find the velocity, and this velocity is called instantaneous velocity. Instantaneous velocity means the velocity of the object at a certain moment, at a certain instant. So what's meant by instantaneous velocity is that the velocity of the object at a given instant. By the way, we are just taking the average at this point, but a small average. But what's meant by average velocity? Can you see? This is the total distance, and this is the total time. So we'll divide the total distance divided by total time. Or if it's velocity, it's total displacement divided by total time. So what's meant by average velocity? It's given by dividing the total displacement of the object from the starting point to the end point by the total time. How can you calculate the instantaneous velocity? You find the point, draw a tangent to the graph, find the slope of this tangent, it is the value of the instantaneous velocity. The instantaneous velocity of the object is given by the slope of the tangent drawn to the curve at the point which is corresponding to that instance. For example, 2 seconds, 3 seconds. So the slope of this tangent is equal to delta d or delta x, which is equal to d2 minus d1 or xf minus xi, final position minus initial position over t2 minus t1. How can you calculate the average velocity? The average velocity of an object is given by the slope of the line joining the starting point and the ending point of the graph. And the slope of this line is given by this relation, which is equal to the total displacement divided by total time, which is equal to the average velocity. So this is the difference between average velocity. This is the average velocity, by the way, and this is the instantaneous velocity. This is the velocity at a certain moment. Let's answer some questions. The opposite displacement time graph, so this is a displacement time graph, or you can say position time graph, represents the motion of a girl that rides a bicycle on a straight road, then the velocity of the girl during the interval AB. So AB, so we are interested in this interval only from A to B, and we will ignore the rest. So can you see? As time passes, the position or the displacement of this bicycle or this girl increases. So this means that this girl is moving, but it moves with positive velocity. Positive velocity means a velocity in a certain direction because the slope is positive. So it is positive and uniform, yeah. Why it is uniform? Because this is a straight line, it is not a curved line. For example, if this is 1, this is 2, no. If this is 1, this is 2, this is 3 meters, for example, and this is 0 and this is 1, this is the numbers, this is a randomly chosen numbers. So the velocity of this object during AB is equal to delta x over delta t. So it's equal to final position minus initial position over t2 minus t1. The final position is 3, the initial position is 0, final time is 1, this is 1, the initial time is 0, so the velocity of this girl is 3 meters per second. Can you see? It is a constant number and it is a positive number. The same question, the velocity of the girl during the interval BC. Can you see? This is B, this is C. Can you see? As time passes, the displacement of the girl doesn't change. This means that the girl is at rest. She doesn't move. Her velocity is 0. How can you calculate it? We will just imagine that we have numbers. This is 1, 2, 3. This is 0. This is 1. And this is 2. So to find the velocity of the girl during BC, we just find the change in the displacement divided by the change of time. So it is equal to final position minus initial position over T2 minus T1. So the velocity during BC is equal. The final position is here. So it's equal to 3. Minus the initial position is also 3. So there is no change. The final time is 2. The initial time is 1. So it will be 0 divided by 1, which is equal to 0. This means that this girl is static. This is wrong, wrong, wrong. And the velocity is equal to 0 means that this girl is at rest. She doesn't move. We have another question. The velocity of the girl during the interval CD. This is C and this is D. So can you see? The displacement is decreasing. This means that this girl was moving in a certain direction, then she is returning back. And she returned back to the initial position, so the total displacement is 0. So to calculate the velocity of the girl during CD, you will use the same formula, delta x, which means change in position or displacement divided by time. So final position minus initial position over final time minus initial time. This is the final position. Can you see? The final position is 0. So it's 0 minus. This is the initial position. I will add the same numbers. This is 1, this is 2, this is 3. So the final position is 3. This is the final time. This is 0, this is 1, this is 2, this is 3, this is 4. So it's 4 seconds minus. This is the initial time, which is 2. So the answer is negative 3 divided by 2. So the velocity of the girl during CD is negative 1.5 meters per second. Negative means she is moving in the opposite direction. Positive and uniform? No. It's negative and uniform, yeah. Why it is uniform? Because we have only one number and it is a straight line. Non-uniform? Wrong. Equal to 0? No. the girl is moving but in the opposite direction. We have another question. Which of the following graphs represents the relation between the magnitude of the girl's velocity during the intervals A, B, B, C, and C, D? Can you see? We have calculated them, by the way. The velocity of the girl during the first interval was 3 meters per second. This is 0. And during the last one, it was just negative 1.5. Negative 1.5. So if we are just talking about the magnitude, the velocity of the girl here is maximum. This is a little bit slower, and this is the minimum. So here it was 3 meters per second. Here it was 0 meters per second. Here it was negative 1.5 meters per second. So the velocity from B to C should be 0. So this is correct. This is wrong, because can you see? This is correct, and this is correct. And the velocity during AB should be faster than that during CD, because this line has a higher slope than this one. So this is rejected because they have the same velocity. This is rejected from the beginning. This is also rejected because this means that the velocity of the girl at AB is less than that during CD, which is completely wrong. But this is acceptable because the velocity of the girl during AB is higher than that through CD. Also, can you see this one is just 2 times as this one, because can you see 3 is double 1.5. So if this velocity is V, this velocity will be 2V. So the answer is B. Now let's talk about acceleration. What's meant by acceleration? Acceleration is equal to the change in the object velocity with respect to time, or it is equal to the rate of change of the object velocity. Change in velocity means final velocity minus initial velocity. Change in time is equal to final time minus initial time. By the way, you are free to just replace initial velocity by u and final velocity by v. So the formula will be v minus u over t2 minus t1. So u means initial velocity. Initial velocity. V means instantaneous velocity or final velocity. Of course, t means time, a, it means acceleration. So what's meant by acceleration? Acceleration, it is the rate of change of velocity, or it is the velocity of it is the change in the object velocity in 1 second or unit time. What's meant by acceleration? It is the change in the object's velocity per unit time, or it is the rate. Rate means something divided by time. It is the rate of change of velocity. So change in velocity divided by change of time will give acceleration, which is equal to final velocity minus initial velocity divided by final time minus initial time. We have some notes. The measuring unit of acceleration is meter per second squared. Why? Because acceleration is equal to delta v over delta t. The measuring unit of velocity is meter per second. We add meter in the numerator and second in the denominator. The measuring unit of time is second, which is found in the denominator. So the measuring unit of acceleration will be meter per second times second, which is second squared, which is exactly meter dot second power negative 2. They are the same. But what if the velocity is in kilometer per hour and time is in hour? In this case, acceleration will be in kilometer per hour squared, but it is not a common unit to be used. What if also v1 is equal to vi is equal to u, which is the initial velocity. v2 is equal to vf is equal to v, which is the instantaneous or final velocity. We have some words which means numbers. For example, if an object started motion from rest, it means that its initial velocity is 0. Also, if we have an object that comes to rest, it means that its final velocity is 0. Or a car stopped, it means also its final velocity is 0. We have types of acceleration. Acceleration by the way, we can classify acceleration into uniform acceleration and non-uniform acceleration. But also, according to the value, we can classify acceleration into positive acceleration, negative acceleration, and zero acceleration. Acceleration is equal to final velocity minus initial velocity over t2 minus t1. If the object is speeding up, this means that its final velocity is higher than its initial velocity. So we have large number minus small number, so the result will be positive. So when we have positive acceleration, when the final velocity is more than its initial, so this means that this object is speeding up. So the acceleration of the object when its velocity increases, so this means that its final velocity is more than its initial. When we have a zero acceleration, acceleration is equal to final velocity minus initial over t2 minus t1. So this is zero. So this is zero because final velocity is equal to initial velocity. When you subtract a number minus itself, so the result will be zero. So this is because final velocity is equal to initial velocity. Finally, what's meant by negative acceleration? Negative acceleration is equal to final velocity minus initial velocity over t2 minus t1. This fraction may be negative if the initial velocity is higher than the final velocity, and this happens when the object is slowing down. So if we have a small number minus a larger number, the result will be negative. Negative acceleration, it means deceleration. So what's meant by negative acceleration? It is the acceleration of the object when its velocity decreases when time. If we have, this is called velocity time graph. If we have velocity time graph and it is represented by a straight line which is coming up, this means that the velocity of this object is increasing and this object is moving with positive uniform acceleration, constant acceleration. Pay attention. It's constant acceleration, not constant velocity, because this object is moving with non-uniform velocity. But here, as you can see, as time passes, the velocity is constant at 20 meters per second. So the acceleration of this object is equal to zero because the slope of this line is equal to zero. But the slope of this line is positive constant. So this means that this object is moving with the uniform velocity and there is no change in the object velocity. If we have a velocity time graph and this graph is represented by a straight line which is going down, this means that this object is moving with negative uniform acceleration or uniform deceleration. They are the same. And this means that this object is moving with non-uniform velocity, but its velocity is decreasing. This is the reason that the change in velocity is negative. Here the change in velocity is zero. Here the change of velocity is positive, but here the change in velocity is negative. What if the object is moving to the right? Do you know? This is positive x, this is negative x. To the right, so the velocity is positive. And the acceleration of the object is also to the right. So this means that this object is speeding up. Why this object is speeding up? Because you are giving the object extra force in the same direction of motion, so it will speed up. What if the object was moving to the right? So the velocity is positive, but it is affected by acceleration to the left, which is negative x. So in this case, this object will slow down. Why this object will slow down? This object will slow down because you are just dragging it by a force in the opposite direction of its motion. So if the velocity is positive and acceleration is negative, negative means in the opposite direction. This means that the object is slowing down. What if the object is moving to the left, which is negative, so the velocity is negative, and it is affected by an acceleration to the left. So in this case, acceleration is also negative. In fact, in this case, the object will speed up. Wow! The object speed up because you are giving the object extra force in the same direction of its motion. This object was moving to the left, and you are giving the object extra force to the left, so it will speed up. in the left direction. Can you see? So if the direction of acceleration and velocity is the same, whether both are positive or negative, the object will speed up. But if the object is moving to the left, so the velocity is negative, and it is affected by acceleration to the right, so acceleration is positive, this object will slow down. Because you are giving this object a force in the opposite direction of its motion, so the object will slow down. So if the direction of the object and the direction of velocity and the direction of acceleration are in two opposite directions, whatever their sign is, the object will slow down. But if the direction of velocity and acceleration is in the same direction, whether to the right or to the left, the object will speed up. Pay attention to this point. So, what if we have, this slide is very important. What if we have velocity time graph? From this graph, we can just get two things. From the graph, we can calculate the acceleration, or we can calculate the total distance, or we can say the displacement distance covered. Total distance covered. If we need to calculate the acceleration, acceleration is equal to delta v over delta t. And since you have velocity time graph, if you calculate the slope, it will be equal to delta y. Y means y-axis over delta x means x-axis. The physical quantity which is drawn over the y-axis is v, and that on the x-axis is t. So the slope is equivalent to the acceleration. So if you want to calculate the acceleration and you have a velocity time graph, you just calculate the slope. Done. But what if you want to calculate the distance? As you know from this triangle, the total displacement divided by total time is equal to average velocity. So in this case, the total distance is equal to velocity times time. As you can see, velocity is drawn over the y-axis and time is drawn over the x-axis. So if you just multiply y times x, this is called area under the graph. So if you have a velocity time graph, and this graph is just like this, and for example, this is equal to 50 and this one is equal to 10, for example, and I'm asking you just to calculate the total distance covered by the object, and I'm asking you also to calculate the acceleration. Let's start with the acceleration. Acceleration is equal to the slope. So it's equal to final velocity, which is 50, minus initial velocity, which is 0, over final time, which is 10, minus initial time, which is 0. So it will be 50 divided by 10. It will be 5 meters per second squared done. So if you have velocity time graph and you want to just calculate the acceleration, find the slope. What if I'm asking you to find the total distance? Then you need to calculate the area under the graph. So this is the graph. This is the area under the graph. What is the shape? What is the name of this shape? This is called triangle. So the area under the graph is the area of triangle. The formula that we are using to calculate the area of the triangle is half times base times height. So half times, what is the length of the base? It's from here to here. So it's from 0 to 10, so it's 10. What is the value of the height? It's from 0 to 50, so it's 50. So it will be half times 500, so it will be 250 meters. This is the total distance. So if you need to calculate the total distance, just calculate the area under the graph. If you need to calculate the acceleration, just calculate the slope, but pay attention, this is for velocity time graph, not for position time graph. This is for velocity time graph. Let's answer some questions. From the opposite graph, describe the type of the motion by which the body moves within 12 seconds. Can you see we have three intervals? The first interval is from 0 to 4, I will call it A. The second interval is from 4 to 8, I will call it B. And finally, the third interval from 8 to 12, I will call it C. So we have A, B, C. Can you see the small letters? A, it is from A to B. B, it's from B to C. C, it's from C to D, okay? As you can see, this is velocity time graph. Since we have velocity time graph, its slope will give acceleration because its slope is equal to delta y over delta x, which is the acceleration. Can you see this is a straight line? So the slope is uniform. But this is straight line coming up, so the slope is positive uniform. And the slope of this graph is equivalent to acceleration in physics. So this means that the object is moving with positive uniform acceleration during the interval from A to B during the first 4 seconds. But what about the interval from B to C? As you can see, as time passes from 4 to 8, the velocity is constant at 20. So this means that this object is moving with zero acceleration or with uniform velocity, which is equal to 20 meters per second. What about the interval from C to D? Can you see the velocity just decreased from 20 back to 0? So this means that this object is slowing down and this object is decelerating until its car stopped or this object stopped. So this object is moving with negative acceleration until it stops or stops. This is the description. The second part of this question, calculate the acceleration during each part. The formula that we are using is acceleration is equal to delta v over delta t. Delta means change. Change in velocity means final velocity minus initial velocity. Delta t means final time minus initial time. So during the first interval, second interval, and third interval. First interval from A to B. Acceleration is equal to final velocity minus initial over t2 minus t1. This is the interval that we are interested in. What is the value of the final velocity? We will go to the final part of the stage, then we will go to the y-axis, it's 20. Minus what is the value of the initial velocity? It's 0. What is the value of the final time? It's 4 minus initial time is 0. So it's 20 divided by 4, it's 5. And the unit, since this one is in meter per second velocity and time is in seconds, so it will be 5 meters per second squared. What about the second stage? The second stage, it starts from the 4th second, time equal 4 to time equal 8. So what is that? As you can see, there is no need to calculate it because can you see the velocity is constant. So this means that during BC, the acceleration is equal to 0. But what if you want to calculate it? The final velocity is 20. The initial velocity is also 20. The final time is 8 minus initial time is 4. It doesn't matter because the numerator is equal to 0. 0 divided by anything is equal to 0. What about the final stage, which starts from time equal 8 to time equal 12? So the acceleration should be negative. So from C to D, the acceleration is equal to final velocity minus initial velocity over t2 minus t1. So it's equal to, at time equal 12, the velocity is equal to 0, minus at time equal 8, the velocity is equal to 20, over final time is 12, initial time is 8. So it's negative 20 divided by positive 4 is equal to negative 5 meters per second squared. So this object was decelerating with the same rate it was accelerating. We have another question. Calculate the distance covered by the body through its motion from B to C, just from B to C. And I will duplicate this slide And I will ask you just to calculate the total distance covered by this object from A to D. Okay, but let's do this first. I told you before, if you have velocity time graph and you were asked to find the distance, you will not find the slope, you will find the area under the graph. But as you can see, not the whole graph, because this question is interested in the interval from B to C only, this one. So the area under this graph is the area of this shape, which is the area of rectangle. So distance is equal to area of this rectangle, which is equal to length times width. The value is its length. It's extended from 4 to 8. So the length of this line segment is 8 minus 4, which is 4. Times, this is the height. It's from 0 to 20, so it's 20. So the total distance covered is 80 meters. Done. Now this is my question. I'm asking you just to find the total distance from A to D. A to D means the total distance covered. So you need to find this total area. I will calculate it to you by two methods. One which is not smart and another one which is smarter. Okay. We can just divide this area into three parts. This one, which is the area of the triangle, and this one, which is the area of another triangle, and this one, which is the area of a rectangle. Then we will add them together to find the total distance covered. I will call this area 1, this area 2, and this area 3. We need to find the first distance. So the shape of this, the name of this shape is a triangle. So the area of triangle is equal to half times base times height. You will use the formula from geometry according to the shape. So it's half times, what is the value of its base? It's extended from 0 to 4, so it's 4 times. What is the value of the height? It's extended from 0 to 20, so it is 20. So divided 2 equal 1 divided 2 equal 2, so it's 40 meters. So this is the first distance. The second distance, can you see? The shape of this, the name of this shape is rectangle. The area of rectangle is length times width. Its length, it starts from 4 to 8. So it's 8 minus 4, which is 4, times the height. The height extended from 0 to 20. So 0 times 20 minus 0, it's 20. So this one is 80, like we have calculated before. The third distance is equal to the area of this triangle. The area of triangle is half times base times height. So it's half times its base. It starts from 8 and ends at 12. So 12 minus 8, it's 4. And its height starts from 0 to 20. So it's 20. So it will be also 40. So to find the total distance, you just add D1 to D2 to D3. So it will be 40 plus 80 plus 40. So it will be 160 meters. Done. Can you see? This is a long solution, right? I have a smarter one, a shorter one. This shape, it's called trapezium. We can find the area of the trapezium directly. Area of trapezium. Area of trapezium is equal to half times base 1 plus base 2 times height. This is base 1. This is base 2. Or you can just reverse them. It doesn't matter because 1 plus 2 is equal to 2 plus 1. You can just reverse them. But the two bases, they should be parallel. And this is the height. The height is the side length, which is making an angle which is equal 90 on the two bases. It is perpendicular to the two bases. So this is the first base, and this is the second base. Why? Because they are parallel to each other. So the area of trapezium, which is equivalent to the total distance, is equal to half times base. It starts from 0 to 12 plus the second base. It starts from 4. Can you see? to 8. So 0 to 8. So 8 minus 4 is equal to 4 times the height. The height is the perpendicular line from the which is joining the two bases. So this is 0, this is 20, so the height is 20. So the total distance in this case is equal to half times 20 is 10. Then 12 plus 4 is 16. 10 times 16 is equal to 160 meters. Can you see this is the same number, but here it is done in one step only. So this is a smarter, shorter solution that will save time in the exam. We have another example. The opposite graph represents the relation between the velocities of two bodies, A and B, and the time. So the difference, can you see the difference between their displacement? This means that we need to calculate the displacement of X, the displacement of A, which will be higher, by the way, and the displacement of B, which will be smaller. And we need just to find the difference between them. And the difference between them will be the answer. So this is called velocity time graph. And from the velocity time graph, if you need the displacement or the distance, you need to find the area under the graph. So for A, this is the area under the graph. By the way, this is also a trapezium. If you can see it is a trapezium, you can just join this line. Now you have a triangle and you have a rectangle. You will find the area of each, then you add them. The area of the triangle is equal to half times base times height. Base is equal from 0 to this number, it's 5. Height is from here, which is 6, to there, which is 10. So 10 minus 6 is equal to 4, so it's 4. So this will be 10 meters. Then the area of this one is equal to the length, which is 5, times the width, which is 6, so it's 30. So 30 plus 10 is equal to 40. Okay, but I don't like this way of thinking. We can just do it in another way, just by doing this, and we can just find the area of this shape in one step. How can we do this? Can you see? This is the first base and this is the second base. Why I'm taking these two bases? Because they are parallel to each other. And this is the height. Why I'm taking this one as a height? Because it is perpendicular on the two bases. So this one is the height. This is base 1, this is base 2, or you can just reverse them. So the displacement covered by A is equal to half times base 1 plus base 2 times height. So half times base 1, this is base 1, it's extended from 0 to 6, so it's 6, plus base 2, it extends from 0 to 10, times the height, it extends from 0 to 5. So now we have half times 6 plus 10 is 16 times 5. Half times 16 is equal 8. 8 times 5 is equal to 40. Can you see? We got the same number, but in one step. So this is the first part. The second part, we need to do the same for B. So the displacement covered by B is equal to. Now this shape is just a triangle because it's starting from the point of origin. So it's equal to the area of triangle. The area of triangle is equal to half times base times height. So half times the base, it extends from 0 to 5. So it's 5. Height, it extends from 0 to 4. So divided to equal 1, divided to equal 2, so it's 10. This is not the answer, and this is not the answer. We need just the difference between the displacement covered by A and the displacement covered by B. The displacement covered by A is 40. The displacement covered by B is 10. So the difference in them is 30. This is the answer. So the answer is C. In this question, the diagram shows the speed time graph of a motion of a car for 4 seconds. What is the distance traveled by the car in the 4 seconds? We said before, if you have speed time graph or velocity time graph, the area under the graph represents the distance. So how can we find the distance in one step? I told you to find the area of trapezium. This is called trapezium. This is the first base, this is the second base, and this is the normal. This is the normal line. So this is the first base, this is the second base. I will write base 1, base 2, you can reverse them. And this is the vertical line which is perpendicular on the two bases. This is the height. I will solve it in another way if you are not happy with this one. So the total distance in this case is equal to half times base 1 plus base 2 times height. So half times base 1, it's extended from 0 to this number. It's 1. Plus this one extended from 0 to 4 times the height, it extends from 0 to 10. So divided 2 equal 1 divided 2 equal 5. 5 times 5, it's 25 meters. So this is the total distance. Done. What if I will duplicate it? What if you are not happy with this formula? And you need just to convert it or divide it into two shapes, two regular shapes. One of them is triangle and the other is rectangle. You can just do this. Now you have a rectangle and you have a triangle. I will call this 1, I will call this 2. So the total distance covered during 1, it's equal to the length times width. The length is 0 to 1, it's 1. The width is 0 to 10, it's 10, so it's 10 meters. The second distance is equal to the area of this shape. This shape is a triangle, so its formula is half times base times height. So half times the base, it extends from 1 to 4. So its length is 4 minus 1, which is 3. Times the height, it extends from 0 to 10. So it will be 15 meters. So the total distance in this case is equal to d1 plus d2. So it will be equal to 10 plus 15. So the total will be 25 meters. Can you see? The same answer, but in more steps. You are free to use any. Just use your mind. The graph shows the movement of a car over a period of 50 seconds from the beginning to the end. What was the distance traveled by the car while its speed was increasing? Can you see? The question is not asking about the total distance. It only asks you about the total distance covered while the car was increasing. As you can see here, the speed of the car was constant speed. So this one is not included. Can you see this one? This was a decreasing speed. So this one is also not included. What about this one? The speed was increasing from 0 to 5 to 10 over 20 seconds. So you need just to find the area of this part, because this is only the interval in which the car's speed was increasing. So the answer should be 100. How can we calculate it? So area under the graph, because we are searching for the distance. This is the area of triangle, half times base times height. Half times, what is the value of the base? It's from 0 to 20, so it's 20. Times what is the value of the height? It's from 0 to 10. It's from 0 to 10. So it will be half times 200. So it will be 100 meters. This is the distance. This is not the total distance. This is the distance when the car was speeding up. For this question, find the displacement covered from time equals 0 to time equals 3.5. So from the beginning to the end. Can you see? This is a velocity time graph. So to find the distance, you just find the area under the graph. You can do it one time by finding the area of this trapezium. This is base 1. This is base 2. This is the line which is perpendicular on them. This is the height. So to find the total distance directly, you find the area of this trapezium. So it will be half times base 1 plus base 2 times height. So it will be half times base 1, it's extended from 0 to 2, plus the second base, it's extended from 0 to 3.5, times the height, it's from 0 to 15. So this one is equal to 7.5 times 5.5. We will use the calculator. So it's 7.5 times 5.5. So it will be 41.25 meters. So this is the answer, and this is wrong. If you are not happy with this solution, we can just divide this shape into two shapes. You can go from here and just make a straight line. So now you have a rectangle, I will call it 1, and you have a triangle, I will call it 2. You will calculate the first distance by multiplying length times width, because this is a rectangle. Its length, it's extended from 0 to 2, it's 2, and its width, it extends from 0 to 15, so the total is 30. For D2, this is a triangle, so you use the formula half time base times height. So half times the base, it extends from 2 to 3.5. So 3.5 minus 2, it's 1.5 only. Times the height, it extends from 0 to 15. So we have half times 1.5 times 15. So it will be 11.25 meters. So the total distance in this case is equal to D1 plus D2. So it will be 30 plus 11.25. So it will be 41.25 meters. Can you see? Is the exact number, but in more steps. Okay, now we have covered the topic force and motion.